So far in our little algebra series, we've looked at the basics of equations and expressions and polynomials and all that good stuff. But what we haven't touched upon yet is that actually within them equations, there's actually a lot of geometry hiding, and we're going to explore a bit of that today. So here's what we're going to do is, alright, let's say that you are given an equation, something just as simple as y equals x. That's what we're going to start with. I'll do another example, I imagine. But, alright, so let's just think about how we can represent this geometrically. So what I'm going to do is I'm going to do a table. So here's x and here's y. So if I plug in x equals 0, then what value does this equation tell me that y is? Well, y had better also be 0. And let's look at if x equals 1, then y had also better be equal to 1. And y is always equal to x, that's kind of just what this is saying. So we get 2, 2, 3, 3, 4, 4, and so on. And this is just the range I'm going to use. Alright, so now we have this thing, and this thing is called a coordinate plane. Sometimes you might hear this referred to as a Cartesian plane or Cartesian coordinates. That's not really important. But what is important is how we're going to show that there's a geometry hidden within these equations. Alright, so what we're going to do is, well, we're going to say that this point here, the origin, is the point 0, 0. And I'm not going to write that in because this is going to be messy, but this is 0, 0, and hey, would you look at that? We have a point here that's 0, and a point here that's also 0. So, if we have x equals 0, here's sort of a geometric visualization of x. We call this the x-axis, and we call this the y-axis. So, at 0 for x and 0 for y, we're going to put in a point here. Alright, and now let's look at this. We've said that if x is equal to 1, then y is also equal to 1, so let's find 1 on our axis. So we'll call this point 1, this is where the first line is. So if we're at 1, well then the line y equals 1 had better be on there as well. And so this point here is also, we're going to say this is true. And we're going to keep going as well, so x equals 2, then y is also equal to 2. So here's x equals 2, here's y equals 2. Let's find out where they both meet, and it's at this point here. And again, we get x equals 3. Here's that point, and here's y equals 3, so let's look at where they meet up, and it's at this point here. And the same thing for 4, and maybe you notice that there's kind of a pattern emerging here. So we're going to get one like this as well, and up here, and up here. And I'm not going to draw in the rest of them. But this table, it's not necessarily representative of everything. Because, well, let's imagine that there's x equals 0.5 on there. Well, then y would be 0.5, and that would be a point somewhere here. So what we do is, instead of just plotting individual points, we're going to draw a complete line that goes through this. My pen would work, and it should hit sort of the corners of all these boxes, and it's going to keep going. We've got no reason to not go through the negative numbers as well. And so that is the geometry of this equation. So we get a nice straight line, and in fact whenever you have an equation that is sort of similar to y equals x, as in there is only a first power, so remember, so it's nothing that looks like y equals x squared or x cubed. So long as the power is 1 for x and 1 for y, you're always going to get this straight line. And actually we'll use that to look at another example if I just clear this. Alright, so let's do that. Let me just get coordinates back. So let's look at the equation instead of y equals x plus 1. Alright, and then we're going to do the exact same thing again. We're going to draw in our table, so we have x here, y here. And again, I'm just going to start off at 0, 0. Well, not 0, 0 actually. So if we plug in x equals 0 here, then we get y equals 0 plus 1, which is just 1. And let's look at x equals 1 next. Well, then we're going to get y equals 1. So we've just plugged in x. 1 plus 1, which is just 2. Same again. Let's look at x equals 2. Then we're going to get y equals 2 plus 1. 2 plus 1 is 3. Y is equal to, if I put a 3 in here, 3 plus 1, then y is equal to 4, and why not, we'll just do one more. So we get, let's try x equals 4. Then we're going to get that y is equal to 4 add 1, which is just 5. And so what we're going to be left with is a table that looks something like this. And what we're going to do is same as before. So we're going to go x equals 0. So it's going to be somewhere on this line. But we know that the y value for this is 1. And how would you look at that? It's this point here. When x equals 1, so that is when we're somewhere on this line here, it says that y equals 2 and y equals 2 at this point here. When x is equal to 2, y has to be equal to 3, so that's this point. X is equal to 3, y has to be equal to 4, which is this point here. And when x is equal to 4, y has to be equal to 5, that gives us this point here. And you're going to see that we're going to end up producing a line that looks something like this. If I draw that in nicely. That's not too bad. So, what we can see is that we've got another line here. And this is not always going to be true that you're always going to produce a line. And let's look at an example where the geometry is a bit different. So let's get rid of this. And I'll do, I guess, what would be the simplest case of when this isn't true. Let's look at y equals x squared. Okay, so we're going to do the exact same process. It's always the same process. So we're going to make this table here, x and y. And if x is equal to 0, we're going to plug that in here. If this guy's 0, the entire right hand side goes to 0, so the entire left hand side has to go to 0 as well. So y is going to be 0, and we get 0 here. So let's try if we put x equals 1 into this thing. So we get y is equal to 1 squared. 1 squared is just 1, so we're going to get 1 here. And let's look at x equals 2. If we put 2 into this, then we're going to get that y is equal to 2 squared. 2 squared is 4. And whoop, I've wrote that in the wrong one. That should be x equals 2, y equals 4. Get rid of that and change that. And I'll do x equals 3. Y is equal to 3 squared. We get that that's 9. And the interesting thing with an equation like this is actually when we go into negative numbers. So I'll do a separate well, it's not really a separate table. Like if you imagine we had more room, we could draw these in, but it doesn't really matter. So let's let x equals negative 1. Right, so we get that y is equal to negative 1 squared. A negative times negative is a positive, so we're just going to be left with this guy is equal to positive 1. And we're going to look at next, if we let x equal negative 2, negative 2 squared is just going to be positive 4. And negative 3 squared, plug that in for what x, then this is going to be positive 9. So if we actually plug these in, x equals 0, y has to be equal to 0, we're going to get a point here. X equals 1, y has to be equal to 1. When x is 2, y has to be equal to 4, so that's 1, 2, 3, 4. And when x equals 3, y has to be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be up here somewhere. Let's just say it's there. Alright, so this is where it gets interesting. So if x is equal to -1, so that's going to be on this side, then y is equal to +1, and +1 is here. So you get a point here. And then x equals -2, it's here. -2, y equals 4. 1, 2, 3, 4. And similarly, for x equals -3, we're going to get a 9 up here. And what you end up with is you get this shape that is called a parabola. And a parabola, very interesting, because if you look a bit further into it, it's known as something called a conic section. And that's probably a bit out of the scope of this video, but yeah, so the interesting thing here that we really need to take away from this is that within every single algebraic equation, there is a shape that's hiding within that equation when you plot it on these graphs. And we'll look into a bit more as to why these things are interesting. And yeah, thank you so much for watching. Hopefully this has given you a basic idea on how you plot graphs. And yeah, like, subscribe, ask questions on Reddit. Thank you for watching.